Hello everyone, and welcome to another Stat385 video. So in this video, we are going to get started with R through RStudio. So I'm going to open up RStudio. Okay, and let's see here. I want to open up my, looks like I'm already in the R project for this class. So you can see here, home, desktop, Stat385, and I'm in the quiz directory. So I'll just back out, delete these, and we will create a new environment here to write, edit, then test code. Okay, so in the book, you can see that, or in the reading, that you can see that, like, first of all, there's batch mode versus interactive sessions. Batch mode would be using R to write a script and then running that script somewhere in the background, and then output would be saved on your computer. You wouldn't see the process. It's very, very useful for like more large scale projects, but not something that's immediately useful to us now because we still need to learn what R and the types of programming that we can do are. And then batch mode could potentially become useful. So interactive mode, we could use interactive mode through R directly, but that is command line only, and it just isn't very user friendly. So that's why we are using RStudio, which is just what you see right here in front of you. So we have our panes, panels, whatever, where we have a text editor here, not like a rich text editor like you would see in Microsoft, like Word or something like that, but a text editor that will allow us to work with plain text and allows for us to easily write our code down. Okay, so I've created a new script using the keyboard shortcut. If you don't know how I did this, then you can see the notes. Okay, and now let's just try running some code, which I will just copy directly from the notes. So here, basically in this class, in this lecture video, what we'll do is just show some of the basic operations and calculator abilities of R. So like stuff that would replicate what you would see on like a basic graphing calculator, etc. And so we can demonstrate that R can serve the role as just a basic calculator before we show that it can do much, much, much more. Okay, so for instance, I have this first line. You could just copy it into the console directly and then run it. But a better way to do it is to run the code. So if I click run, it'll run that line and then go down and run the next line. However, there's a keyboard shortcut to just do that automatically. So you can see that all of these, addition, subtraction, multiplication, division can all be done. And also, you can see what I'm doing here, exercise to the reader to figure this out. And I'm gonna hit Command run and run everything. So let me just demonstrate that again. Okay, so you can see, Okay, so you can see it all run here. Okay, so yeah, so it performs basic operations. You may see something like, it also has, you can string together these binary operators, and R will follow, or has its own built-in operator precedence, which if you see this string right here, you probably figure out what the result would be by traditional order of operations training in a math class, and R will follow the same rules. Okay, so you could string all this stuff together this way to follow operator precedence. I think that this is hard to read, so it may be more beneficial to just include the parentheses directly, and you'll still get the same result. But this, I imagine, is easier to read than what I had earlier, which was this. Okay. And to see all of the operators to see an exhaustive list of ordering, we can run the question mark syntax. So question mark here is a built-in way for R or you would tell R that you want more information on a particular function or concept. And if it's built in, then we can see it. So I'm going to run this, and then you can see that in this panel, R switched over to the help panel, and you can see descriptive information on syntax and operator precedence. Now, This is very, very important. The help function is extremely important, and this help panel is extremely important, of course. But right now, this might not mean much to you because you don't have a lot of training in R to understand the information that is being communicated to you at this moment. And then, we'll continually reference these help pages, and as we build understanding throughout R, these types of this information will become clearer and clearer and become actually useful. For me, it's incredibly useful when I'm working on the tasks that I work on. If I need to use a new function or a new package or just something that I haven't seen before in R to get a sense about how to actually use it. And so when I'm working on this, I can see the quick details and then just scroll all the way down to the examples to learn more. Okay, so continuing on. Yeah, I can use, R can also just, type and return numbers. So that's just returns 42 or negative 42, which is an operator times a number. And if we scroll down here, and we've seen this before in the above, we have this little 1 followed by the number. And we'll have more on that later. Basically, it's just a vector with one element. This is indexing that element, but we'll get into that in a little bit more detail. Okay, so R has, as we've seen, standard binary operators, which we are likely already familiar with: addition, subtraction, multiplication, division. There's also exponentiation, so I could take this and raise it to the third power and perform my calculation this way. Okay, so we have here division with exponentiation, subtraction, and multiplication. Run it all that we want, but yeah, we have exponentiation. Okay, I think it's very tempting to, we have right here the explicit the specific operator for setting up a multiplication. It seems tempting to want to do something like, if we were to have some sort of expression in parentheses where we would understand this to be 15, R will complain. This type of notation, the parentheses here, is usually relevant for functions. So we can see we attempt to apply non-function. R doesn't like it, so it complains. So actually, to set up the multiplication, we have to use the operator. And yeah, I like to add spacing when possible because I think it's easier to read, but you can, of course, compress this. Okay. Then there's also two other binary operators that you may not be familiar with, but are often used in programming. I've used them before in functions that I have written to do statistical tasks. So this would be modular arithmetic. And so the idea would be that you're essentially taking 7, or seeing how many times 5 goes into 7 and then pulling out the remainder. So if I had 5, this one isn't very useful, but you can see that 5 goes into 5 one time and there's no remainder. Similarly, 5 goes into 10 2 times, no remainder. But if I were to change that to 11, then I get 1 remainder. And then integer division, which would be, let's just copy both of these, how many times 5 goes into 7. How many times 5 goes into 11. Okay, so this is I've used this modular arithmetic before in functions I've write. And integer division I haven't had to use as frequently, but it's something that, nonetheless, it's a binary operator that R has built in and can be used when needed. Also, R has some basic functions already programmed in for your usage in base R. So I think I've said before that R is like as a programming language is something that comes with a ton of statistical tools. Like when I do my research, if I'm doing something that I think is going to be useful to other people, and other people will want to implement the methods that I create or create with students or collaborators or whatever, then I will, produce like software to implement that method. So R has a whole just host of packages that you can obtain to do all kinds of different tasks. That being said, R has built-in functions in base R or stats or whatever that can implement some basic tasks. Like this one, square root, it's going to do basically exactly what you think. Square root of 9 is 3. And it has absolute value. So here, this is a positive number, so it just returns it directly. And if I put in negative 42, then it returns 42. Okay, and then we can see log. And here, note that log is sort of ambiguous, requires a base. In R, R will always be the natural logarithm. That's what it will run as a default. And if you want to, go with a different base, you can see here there's built-in function for log 10, or you can, with an argument, which we'll cover later, you can specify the base directly. There's also 2 is default, or again, like I said, you could specify the base directly. Oops. There we go. Just out of curiosity. Yeah, we can see, we can change it. Okay, to other things. Okay, right, so there is no ln, the default is log. Unfortunately, there's no Euler's constant in R. However, there is an exponentiation function, which will do the same thing, and you can see that since log, which always means natural log, is the inverse function of the exponent, then this returns 1. Just to make sure. Yep, okay, good. All right, so great. We also, R has built into it trigonometric functions. So sine, cosine, tangent. Okay. And as we said in a previous video for last week's practice lab, R, we can guess at the number of digits of pi. However, R has it built in. So, and getting into some of the details here, R stores, of course, pi is an irrational number with infinite number of decimals. We can't represent that in a system that has finite memory, system being the computer, which has finite memory. So R will has an integer representation of pi built in, has many more decimals than what we can display, than what is displayed here, but this is just returning some description of what is actually stored. Okay, so now where things get a little bit, I guess, confusing is in what happens when we do sine of pi. Okay, so right here, we know mathematically that sine of pi should equal 0. However, due to the finite precision nature of representing these real numbers and these functions which evaluate real numbers in kind of like finite terms, this calculation does not actually return p or 0, but it returns a number in scientific notation, which is very, very small. So what's outputted here is basically, or is the same, no, I should say basically, to the minus 16. Right, so it's like, yeah, this would have more digits, maybe has some rounding, but it's a very, very, very small number that, due to problems with finite precision, isn't exactly 0, but can be understood to be 0. Okay, similar problem with tangent, and cosine seemed to actually work pretty well in this case. Okay, so Yeah, this floating point arithmetic, there's some mention of it in the notes, but it's computer scientists attempt to get around these particular problems of expressing real numbers, functions that are understood to evaluate real numbers in finite precision. So this is just an issue that is going to be prevalent in just scientific computing in general. Okay, going on. R also has what we would call special functions. All right, so you can see by going to the help page, you can see the different types of special functions that are apparent in R. So let's try one, factorial 2. Oh, that's not interesting. Factorial 3. So factorial of 3 times 2 times 1. Something that's very, very useful in statistical computing. If you've seen like a binomial distribution before, you would use factorial. So something that is useful in statistics. Also, there is rounding, round pi, just round to the nearest whole number. 3.6 or 4.6, sorry. Let's see if we do 4.5, what happens? Okay, so it follows convention of rounding down. Okay, and then there's floor and ceiling, which are pretty self-explanatory. So if I were to take floor of 4.1, this is just rounding down. And ceiling, the opposite, would just round up. Oops. Okay, 4.1 goes up to 5, ceiling of 4.9 goes up to 5 as well. Okay. And trunk, which just pulls out the decimal, or the whole number part. Okay. All right, so round also allows for us to round up to specific number of digits by going into the function. So say I want to round pi up to 4 digits, then I can specify an argument inside of the function in order to achieve that task. Okay, so you can see 3.14159, so it rounded up to 6, the last decimal point there. Okay. We can also express numbers in R using scientific notation. So say I want to instead, if I want to, I can write 5,000 as 5e3, which is the same thing as 5 times 10 to the third power, or just 5,000. Okay. Similarly, I could take a really small number. 10, or sorry, oops, what am I doing? E to the negative 8, we'll say. Let's see until we get one that actually writes out. Okay, see, okay, I can write it in scientific notation, and then R will, as default with this one, display all of the decimals. Okay. All right, so as said here at the throughout the video is, so we have these different binary operations, these different class of special functions, and all these functions in between. And if we get stuck, we can always use the question mark and read the R documentation behind what this function does. So the documentation page will contain, the function name, sort of the package that's from. This is just base R. So when you download R, you get base R, which is this, set of additional tools. In this case, it contains the round function and many other functions. It gives you a just, like a title of the function, description. This is actually okay, so I should say with round, it's going to provide a documentation page for round and similar functions to it. So this is just, right, so round is the function name. It is in base, And then this is just the help page for functions that do rounding of numbers. So here's also ceiling and floor and trunk, things that we've seen. And then signif does scientific notation. So round, the specific function, rounds the values in its first argument to the specified number of decimal places. And you can see details for more information here. And then there's stuff that won't be immediately obvious to us. And then if we go down, we can get examples of all of these functions which are rounding numbers. So generally speaking, when I'm using the help page, I want to see like a description of what the functions are, what the arguments are, and whatnot. And then if I need more help on details, I'll read that. But I generally skip down to the examples and try to like run it and compare to see what sort of expected output I would get from these examples. Okay. All right. So this is a brief look about what R can do as a replacement for your complicated and fun graphing calculator. And this is just scratching the surface of what R can do. And then as promised and as hinted at in previous videos, next time we will get into some of the power of R and investigate objects and functions. Okay, so thank you for paying attention, and I will see you next time when we discuss objects and functions. All right, bye.